Hello. This video is going to go over the instructions for creating a graph from a set of data points. We have a separate video that actually covers steps 5 and 7 that talks about how to scale these small boxes. It's called Scaling a Graph or Graph Scaling. You can also find that under my YouTube videos. But this video, is going to explain just kind of the general graphing process. There will be a separate video that will talk about the second set of these instructions, finding the slope of a line. If our graph happens to be linear, that will be called finding the slope of a graph. So you can look for that video, which will be the next one in the series. But today we're just going to concentrate on how do we actually take a set of data points and to put them appropriately on a graph. So these are the data points that we'll be using today. They came from a little lab activity where we had a bunch of different circles and we measured their diameters and the circumferences to the nearest tenth of a centimeter all the way down. They are not necessarily in numerical order. We'll find sometimes when we do measurements and take measurements of different things, sometimes they do just go from smallest to largest. Sometimes they jump around like these. It just kind of depends upon the data that we're measuring. In this case, the numbers do tend to skip around a little bit, but for each one of these, we do have a diameter and a circumference. Okay, so I'm just going to follow down the set of instructions. Right. Step number 1 says we need to determine which measurement is the dependent variable and which one is the independent variable. Generally, the way that we do graphs is we have a y-axis, a vertical axis, and an x-axis that's horizontal, and we tend to graph the independent variable on the x or the horizontal axis, and then the dependent variable along the y or the vertical axis. There are some times where we will actually break that rule and do them in the other order, but this is the general order that we use for graphing. Okay, so which of these is which? Well, the way I tend to look at it, we look at these two variables. Right, the independent variable is the one that we are initially changing to see what happens, and then the dependent variable is what happens after that. In this lab, I don't know if it's immediately obvious, but the circumference actually depends upon the diameter. If we make a circle of a larger diameter, then that also changes the circumference. The circumference depends upon the diameter of the circle. So since the circumference depends upon the diameter, the circumference is the dependent variable. Right? The diameter is independent. It's what we're looking at or changing first to see what happens. So we will be graphing the diameter numbers along the x and the circumference along the y. Okay, that actually covers step number 1. For step number 2, we need to determine the largest value for each of these measurements, for each of the axes. Our largest circumference happens to be 65.5, and the largest diameter happens to be 20.6. For this graph, the largest values happen to match with the data points. That's not necessarily always true. Sometimes the largest y value might be here somewhere in the graph. The largest x value might be somewhere completely differently. But in this case, they do match for the same data point. We do have the largest circumference where we have the largest diameter. For the next step, we need to find out how to scale the large boxes on our graph. This is our piece of graph paper. The graph paper that we use in this class has 20 boxes up the side. It has 15 boxes across the x-axis going horizontally. Right. So what we need to do is look at our largest values and divide by the number of large boxes we have going in that orientation. Since our circumference, which is the dependent variable, has the largest number overall, the 65.5, we're going to put the graph paper in portrait orientation. If our largest value was an x value, right, we would move it so that it would be more landscape. But since 65.5 is the largest value overall, we're going to put our graph paper this way. And then to find out how to scale the large boxes up and down, our process is we take our very largest value, which happens to be 65.5, and we divide by the number of boxes going that way. We've decided which orientation our paper is going to be, and then we do the math and we get 3.7 something something something. And that's all we need, because what we do is we take that decimal and round up to our next biggest whole number, which is 4. So we're going to count by 4s for our dependent or circumference variable. And we'll get back to that in a moment. We do exactly the same thing for the x or the dependent, or excuse me, the independent or the diameter. We take the 20.6, which is the largest value that way, and divide by 15, which is the number of boxes that we have going horizontally. And we get 1.3 something something. Again, the decimals don't really matter after that point, because we know that our next largest whole number is the number 2. So we are going to count by 4s going vertically up the graph, and count by 2, going horizontally. Okay, so going back to our graph paper, that means we're going to count by 4s going up. We always start with 0 in the corner of the origin of our graph, going both directions. And the reason that we're using the method that I set up is because we want our graph to cover the majority of the graph paper in both directions. We don't want tiny little graphs just down in the very corner of our paper, because when we do that, the data analysis part, which might mean finding the slope or just looking at the general shape of the graph, sometimes it's very hard to tell exactly what's going on, and there's a lot of error with a very small graph. So we want to cover at least half of the graph paper, if not more, in both directions when we create this graph. So using what we found out, we need to go to 65.5 vertically, so we said we're going to count by 4s. So we start with 0 in the corner, and then each dark box we label off counting by 4. So that's 4, 8, 12, and then continuing up 16, right, 20, 24, 28, 32, 36, 40, and we just keep numbering as far as we need to. So 44, 48, 52, 56, 60, 64, 68, and then we can stop. Our biggest number is 65.5, which is going to be somewhere between these two. So that's really all the farther we need to go vertically. So we go down to the bottom of the paper, and horizontally we said we were going to count by 2s. So we'll count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. And our largest value was 20.6, so that's where we can stop horizontally. Okay, so now we've actually got our graph set up. We do want to label these axes always. Across the bottom, we are measuring the diameter, and we measure it in centimeters. We always want to put a parentheses, and then the units we're using inside of the parentheses, and we can abbreviate things like centimeters with kind of the standard abbreviations for things. Up the side, we are having circumference. I like actually turning the paper sideways and writing that label. Some people leave it vertically and just start with a CIR and just kind of write it, in this orientation with a C and then an I, and just kind of write it down the page. Whatever works for you is acceptable as long as it's readable. Right, and then we put our centimeters there, and we'll talk about the title and things later, but at least now we kind of have our axes set up. All right. Now we need to look at graphing the points. And we go to graphing the points, none of them are probably going to end up exactly on these dark squares, so we need to go and look at that other video, which is called Scaling a Graph. And then you can figure out exactly where to put these dots. I'm going to assume that if you need to, you can pause this video, go to the other one, and then come back. I'm just going to kind of go from here, and we'll see what happens. Right. Our very first one is 4 and 13.5. So as it turns out, our diameter of 4 is actually right on the line 4, which is the second dark line down here at the bottom. Right? Our y value is 13.5, which is going to be between these two values. So let me zoom in a little bit. Okay, so 4 is still on this second dark box. So it's going to be right along here somewhere, because that is 4. I need to figure out where is 13.5. Well, since we're counting by 4s, each of these small boxes is a 0.8. So this is 12.8, 13.6, 14.4, 15.2, and then 16. Well, the second one I said was 13.6. We're graphing 13.5. 5, which is just less than that. So my dot for this would probably be right about there. Right? We're at 4 going across. We're just less than the 16.6. That would make it about 16.5, so that's my first data point. Right, my next data point is at 20.6 going across. 20.6. If we're counting by 2's, each of these is 0.4. So that's 20.4, that's 20.8. 20.6 is right between those. So we're going to go one line and then halfway across the next box after 20. Right. Up at the top, we're at 65.5. Count it again, and we're counting by 0.8's going up, 64.8, 66.6, so we're going to be right below that line. So let me go back to my other, let's kind of slide this over. Okay, this was the 20 line, and we said it was a line plus a half, and that was 65.6 right there. We need 65.5. All right, so that was 20.6 is sideways there. 65.5 is right below. There we go. I'm going to pause this for a moment and graph the rest of the data points. So I'm just going to put the data table here for a moment so you can see what those numbers are. And if you're creating your own graph, right, I'll leave them here for just a moment. So if you want to practice graphing this, you can do that. I'm going to take a moment and graph the rest of these points. Okay, so I finished with my graph. Let me zoom out here a little bit so we can see what it looks like. So my graph looks something like this. There are 1, 2, 3, 4, 5, 6, 7, and this one's kind of hard to see, 8 points right on my graph. My 8th point is right there. I do need to title my graph. The way we title these graphs, it's always the dependent versus the independent. So what I would title this graph is circumference. Oh, my penmanship's not good on this one. Versus diameter. You know, I might put a subtitle in this like circle graph or circle exercise. We use circles to do this. But in terms of actually creating the graph, that is what we would do. I do want to do slope separately because some of you already kind of have this part down and don't need to watch this, but just need some refreshers on the slope. So my next video will talk about how do we actually create what's called the best fit line, and then find the slope of that, because these do appear to follow generally a linear relationship, which means as the diameter gets larger, the circumference seems to get larger at about the same rate. So if you need to have a refresher on the slope, please watch the next video called Finding the Slope of a Line. Otherwise, thanks for watching.